Okay, yeah. So for non-precision approaches, you can have localizer, GPS, um, VOR, um, NDB. Let's see here. Those are the most. Those are going to be the most common ones. RNAV also can be a non-precision approach. For precision approaches, you can have ILS is the main one. That's going to be the one you'll get the most experience with is ILS, which stands for Instrument Landing System. Um, Other types are MLS, which is a microwave type landing system. There's TLS, which is very uncommon. There's RNP as well. So yeah, there's those are just to name a few. So did you guys get a chance to talk about the transition procedures? So like the SIDS and the stars.
Yes, we did.
Okay. So can anybody on here tell me what a SID is?
A standard instrument departure.
Okay. And what do we use a SID for?
Uh, we use this. I'm not really. I'm kind of lost with that question, but I know that we have certain. It's to keep airplanes in a certain path. That way, air traffic control is less congested. They're not talking. Like it makes the workload easier for them. That's all I know.
Correct. Yeah. Yeah. The entire purpose of SIDS and stars. So SID, like you said, is a standard instrument departure, and basically what it does is it goes. It, they're typically used in high traffic airports, and what happens is as an aircraft takes off and goes down the runway, it starts climbing out, and air traffic control will assign that aircraft a SID. And now airports in general, if busy airports have several different SIDs, but the best way to think about a SID is like take Salt Lake City as an example. It's a major hub airport for Delta Airlines, and what happens is you get all these flights and they take off. Some go east, some go west, some go north, some go south. But a lot of them, they'll use the same runway. So if and they'll start taking out, and as they climb out of Salt Lake City, they're usually going the same direction initially. But like if I have one flight that's going Salt Lake City to Los Angeles, and then another one that's going Salt Lake City to New York, they're going to start climbing out the same way, but eventually one's going to go west, one's going to go east. And so the SIDS, there's several different SIDS, and I'll bring some up. We can take a look at them if you guys want to review it a little bit. But SIDS, basically, they will take the traffic from as soon as they take off the runway, they're basically assigned a SID path. Just think of it as a path, and that path will lead them to the airway or jet route that plane or that flight is going to that it's going to use to ultimately fly to its destination. So, for instance, the one so if you're taking off, you'll have SIDS that go to the north, SIDS that go to the east, SIDS in every direction. Typically, depending on which way the traffic is taking off, like in Salt Lake City, the runways go north and south. And depending on the wind, you want to take off into the wind, but as the planes take off, they start out flying north. Let's say if the wind is blowing out of the north, to the south, then the planes will take off into the wind flying north. And then as it takes off, the one going to LA will be assigned this particular SID that has a path that leads over to a jet route that leads down to Los Angeles. and the other one will be assigned a different SID that leads onto a different route that gets him onto a jet route that eventually will take him out to New York. So and the reason that they do that is if there weren't SIDs in, so a SID in a star is obviously the opposite of a SID. It's an arrival route into a major airport. But a SID, while we're just talking about that, a SID is simply just the reason it helps us, and the reason why hub airports and bigger high traffic airports need them is because there's so much traffic that if ATC had to individually tell each and every flight taking off, coming in and out of that airport, and give them specific turn-by-turn instructions, the airways would be too clogged up to handle everybody. So what happens if we're on this flight going from Salt Lake City to Los Angeles and ATC assigns us a SID, we look at our chart, we take out our charts, we open up the chart to that specific SID, and then as we take off, we know that if we're assigned whatever SID, we are supposed to follow the points on that SID exactly as it prescribes on the chart. So ATC doesn't have to sit there and tell us, okay, now turn left heading 280, now turn left again heading 220, or whatever. They don't have to give you that turn-by-turn instruction. Instead, you follow the path that the SID has. And so ATC knows what you're doing because they assigned you that path. The pilot and first officer know what they're doing because they're looking at the chart, and then they know right when to turn. They know when to climb because the SID not only gives them turning instruction, it also gives them climbing instructions. So after they take off, they know that once they pass a certain intersection, and I'm going to bring one up here real quick. Did you guys have a chance to look at one last night?
Are SIDs all like always the same, or are they like for each individual flight? Like, do you have to plan a new SID every time a new flight goes out, or are they like kind of like presets?
You have to select a SID for every flight. So, but the dispatcher, there's several things that the dispatcher will look at in order to use a SID though. Like, so if you're planning this flight, you're going to see, okay, well, what way is the wind blowing? The other thing is you can bring up the airport and you can see what runway they're using and which one they're landing and taking off on. And a lot of that's going to also, depend on which SID you select as the dispatcher.
Okay, so they're kind of like.
Yeah, Sierra, I'll when I get time, I'll show you on my flight simulator, and I'll kind of point out what I'll show you what the SID is while I'm on the simulator. You'll kind of I'll explain it to you.
I mean, like, I understand what they do. I'm just saying, do you plan a new SID every time a new flight goes out, or
Yes.
are they kind of just like already set in place and then you just pick one that works the best?
Well, SIDs in general are already, they already exist, but you have to go through the list of the SIDs that exist and you have to choose one.
Okay, so they are pre-existing.
Yeah. So,
okay, that's what I was asking. I'm sorry.
Yeah, no problem. So here's one. Can you guys all see this good?
Mm-hmm.
Okay. So this is Salt Lake City. This is called the Severe 3 departure. So just to kind of make sense of it a little bit, and like I said, some of this you may have already seen, but you have the airport right here. Let me see if I can use my little drawing tools. So this is the airport. Everybody can see that. So these are the runways. These white lines in here. So this specific SID is if you are taking off. Let's say you're taking off on this middle runway here, and you're taking off to the north. Now this specific SID is for traffic taking off to the north. And the way you can tell this is because of this arrow, this black arrow right here that basically comes up and turns. Now, if this SID were for traffic that was departing to the south, you would see an arrow on the south side down here, but there's not an arrow down there. That means you can only use the SID taking off to the north. So that's just one thing to look at. So as you use that, you're basically, as if a plane were to take off. Now, if without getting any air traffic control instruction at all, if air traffic control just simply said, okay, flight 293, let's say that's your flight 293, and he'll basically say you cleared to take off runway 34 right, and this runway that I highlighted is 34 right in Salt Lake City. But cleared to take off runway 34 right, and then the next instruction they'll usually give you is, they'll usually say climb via, I'm going to go back to this, they'll say climb via the Severe 3 departure. So that's part of the air traffic control instruction to the pilots. So what that means to a pilot, though, in this case, is that after they take off, they simply just look at this chart and they follow the instructions on the chart. Now, you have to obviously have some basic navigation skill, and pilots obviously do. But what that means is if they're looking at this, they know that as soon as they take off, they start climbing out, and they immediately need to make a left-hand turn heading 263 degrees. And most of this is automated. So typically what happens is they take off, they bring the landing gear up, they bring the flaps up, and then they simply turn on the autopilot, and then they turn a little knob that says 263 and hit the autopilot button, and it'll automatically turn. So that's typically, when you go out in jump seat, you'll see this. But that's what these instructions are. So the first thing they're gonna do is take off, turn left, heading 263. Now, as you can see, that just puts them on this heading, right? So as they're flying out, so now let me get some of that stuff erased. So now they're heading on this 263 heading, basically going straight west. Now, you can kind of see this other dashed line that it goes along this route right here. Ultimately, that's the route that they need to intercept and start flying. So as soon as what happens is, as they're flying west here, you can see this VOR up here. So this is a VOR, this circular thing. That is the Wasatch VOR. And as Garrett has probably gone over with you already, these VORs have radials that come off of them. And so this radial, you can see this dashed line, that is the 193 radial from the Wasatch VOR. So as this plane turns and goes to this 263 heading, what it's looking for on its VOR receiver, which you'll learn about VOR receivers in the systems, and you've probably talked about them a little bit, but what they're looking for is they're looking for this 193 radial, and they tune in to this Wasatch VOR. As soon as they cross over this 193 radial, they turn left again, and they head towards this Edith intersection. Now, I know he's already gone over like intersections and jet routes and Victor routes and things like that. But basically, the pilots see this and they're, okay, we're going to head to the Edith intersection. But in case you're wondering, how do they know where the Edith intersection is? Well, they use these two VORs to find it. So they turn left and they start flying outbound on the 193 radial from the Wasatch VOR, heading towards this Edith intersection. And then they'll know that they get to Edith as soon as they are, because they're flying on the 193 radial, and then as soon as they intercept this 311 radial coming off of the Delta VOR, then they know that that's where that intersection is. And then from there, they basically just start following the instructions, and then they turn left again, now heading 170 towards the Severe intersection. And you can also see the altitudes here. So as they came up here and they took off, they turned left heading 263, then they flew until they intercepted this 193 radial, and then they turned left again. And this whole time, this thing says here, it says flight level 280. That means they climbed up to flight level 280 during this time. And then you can see this next leg here also says flight level 280. So once they get to flight level 280, that's where they're supposed to stop until this actually tells them to go higher, or if ATC tells them to go higher. But if ATC tells them nothing at all, then they know that this is what they're supposed to do. Take off, turn left, going 263, and then when they hit this radial here, they turn left again. Meanwhile, they're climbing up to flight level 280, flying down this way. They intercept this intersection. They then turn more south again, heading 170, continue down to the Severe intersection. I'm going to erase these here real quick and move this up. Once they get down to here, to the Severe intersection, there's a couple of options. They can either continue going straight, or they can take a right. Now, depending on where they're going, they could be assigned either one of these two. So they could go over to the Coaldale transition or the Milford transition. Now, both of these are VORs. However, depending on where they're going, they might turn right, heading 238 right here, and come out this way, or continue heading south, and then my line's not very good, and go down to the Milford intersection. But anyway, if they continue south, they stay at flight level 280. If they turn right, they go up to flight level 310. And then these are kind of the same things you've seen. This is the distance. So the distance from Severe intersection to Coaldale is 241 miles. The distance from Severe intersection to the Milford VOR is 51.7. So does that kind of make sense? So if ATC were to give them no instruction at all, other than just say, you're cleared to take off, runway 34 right, climb via the Severe 3 departure, and then they'll usually say, so the other instruction on the end of this, they'll usually say, so the two options for this SID are going to be the Coaldale or the Milford transition. So ATC at this point, all they have to do, in order to get that aircraft from the ground all the way to either Coaldale or Milford. Does everyone know where Milford is in Utah?
I think so.
Those of you that live in Utah. So Milford is just northwest of Beaver. Okay, so those of you that know where Beaver is, Cedar City, north, So Milford is closer to St. George than it is Salt Lake City, just to kind of give you an example. So these SIDs and stars that you're seeing on here, they are not to scale at all. So it looks like it's a lot shorter than it is, but you can see like this one that goes out to Coaldale, it's 241 miles just from Severe to Coaldale. You can see this first leg up here. This first leg where they turn left is 80 miles. So that's 80 miles there. Then another 27.9. And then, anyway, Coaldale, the Coaldale VOR is on the Nevada-California border. That's how far it is. So just to kind of put it in perception a little bit, SIDS and stars can really take you a long way if you follow it like out to the furthest possible transition. But if somebody was using the Severe 3 departure, and this is where the dispatcher is the one who really picks this, and you're the one doing the planning. So the dispatcher decides, okay, I've got this flight going Salt Lake to LA. Or if it's going to, let's say it's going to Oakland. You can say, okay, well, the wind is out of the north, so we'll use the Severe 3 departure, and we'll take them out to the Coaldale transition. The Coaldale transition, like I said, is out on the Nevada-California border. It's just south of, it's like straight south of Lake Tahoe. Anyway, so from an ATC perspective, though, they can say flight 293, cleared to take off, runway 34 right, climb via the Severe 3 departure to the Coaldale transition. And that's all they need to tell you. If they now typically they're going to, eventually come back on, and they might give you a shortcut, or they might take you a different route if they need to. But if they told you nothing more than just that, that's going to get you from the runway all the way down to really 3/4 of your way to Oakland. If you start looking at this, like if we bring up the actual chart on SkyVector and you can see how far this is, you'll see that it's pretty far. And all of that with just that one simple ATC instruction. Now that gives them their altitude, it gives them their headings, so they can go all the way to Coaldale, and by the time they get there, typically another air traffic control center will have already taken them over anyway. But you can kind of see, like, that's in lieu, that one instruction avoids ATC having to come on and say, okay, turn left heading 263 right here, and then turn left heading 193 here, climb to flight level 280, turn, like this eliminates probably 10 different conversations between ATC and the pilot. So this is where, when we're talking about how it reduces the workload, that's why it reduces the workload. So does that make sense to everybody?
Yes, sir, it does.
Yep.
Okay. And then a star is simply the exact opposite of a SID. It pretty much looks exactly the same. The only difference is you're doing it backwards. So if we were flying from Oakland to Salt Lake, now this is a SID on this one, but let's just pretend this is a star. It looks just the same anyway. So if this were a star, let's pretend that this is the Severe 3 arrival instead of departure. So you would come in on the Coaldale VOR, coming in this way, and you would do it exactly backwards. You would come in on Coaldale at flight level 310, and you would join up with the Severe intersection. Then you would turn north. Now the only difference here, obviously, is it's giving our degrees backwards. But you would descend down to 280, flying up this way, and ATC. So if you're from an ATC standpoint, when they're having you approach into an airport, they're going to basically say you're cleared to descend via the Severe 3 arrival. Now, obviously, like I said, we're just pretending this is an arrival, but let's maybe go and look at an arrival real quick. Let's see. It's Spain 7. Okay, we'll look at this one here. This is the Jammin 5 arrival. We'll just look at it backwards. Now here's our airport. You can see up there. But let's come down here to the bottom. So the possible transitions for here is Milford. So now we see Milford again, or Bryce Canyon. So this is stuff coming up more from like straight south of Salt Lake City. Also stuff from Southern California would use this, but they can either come in on to the Milford transition, but then you can see here as they start descending, you can see like as they cross onto here, they need to be at 16,000 feet. And then you can see the instructions that they're supposed to, you can see the distances. 16,000 feet even, so they still maintain 16,000 feet even up in this area. Let's see here. So now when you start looking at these as well, if you don't see an altitude listed, like you can see that 16,000 feet, it doesn't like it ends at 16,000 feet, but then you don't, as you continue along, you don't see altitudes anymore. You can see the headings, that they're supposed to fly, but you don't see altitude anymore. That typically means that from that point forward, ATC is going to be independently giving you the altitude that you need to descend down to. So, but if you receive no instruction, though, you would not descend below 16,000 feet. So that's ultimately what it means, is you would just keep flying this, but you would stay at 16,000 feet and until ATC actually tells you to start going lower. So, oops. Anyway, so you would just continue flying it. You know, ATC is going to be descending you down, and then eventually they will bring you in, and depending on which way the airport is landing, they'll either turn you off, like at this chip intersection. They'll either have you turn here and line up for a runway, or if they're landing to the south, they'll have you keep going north like this, and then they'll turn you up here to back down this way. So you can have either of those options, just depending on what ATC wants you to do and which way they have people landing. So, but ultimately, the star gets you to a point to where ATC is going to give you the final instructions, and then from there we actually look at the instrument approach to see what the final course is, to line up with like an ILS or any sort of an approach procedure. So in a nutshell, I mean, that's SIDS and stars, but does anybody have any questions on these? Hopefully that was just mostly a review. Now, like I said, a lot of this stuff, this is just us briefly going over this. You're going to see this repeatedly, especially when we get into flight planning. You're going to get all the SIDS and stars that you'll ever want once we start doing flight planning, as well as instrument procedures and everything else flight plan related. So don't feel like you need to like memorize this right now or have a total complete knowledge of everything that I just went over, because you're not going to right now. But just understand the basics. The only thing that you need to understand right now about SIDS and stars is that they are sets of instructions for either climbing out of an airport, a busy airport, or descending into a busy airport. And the ultimate purpose of these is to cut down on ATC and pilot workload and all of the chatter back and forth, and to give people a clear set of instructions based on minimal communication. So this obviously makes the airspace system a lot safer as well. So if a pilot, if everyone's sitting around waiting for ATC to tell them what to do, you can understand why human error alone is going to eventually make it so that ATC forgets to talk to somebody. But in this case, nobody should ever be on the wrong page, because if you're ever wondering where you're supposed to be or where you're supposed to be flying or what altitude you're supposed to be at, all you got to do is look at the chart. If ATC told you to descend via a star or climb out via a SID, then you follow what the chart says, unless otherwise told by ATC to do something different. So there shouldn't ever be any question as to where you should be, what direction you should be heading, and what flight level you should be at. So that's the purpose of SIDS and stars, is to cut down on that congestion around busy airports, and then obviously the workload.
Are these charts on SkyVector also?
These ones that we're looking at are not, but I can show you. So this one that we're looking at here is a Jeppesen chart. Let's go into SkyVector though, and I'll show you exactly where to find this. Now you're not going to see it. It's not going to look exactly the same. Garrett probably told you, but in the flight planning world, there are ultimately two different types of charts. There's the government charts, which is what SkyVector has. Those are the ones that the FAA issues and makes readily available to anybody for free, the flying public. And then there's a company called Jeppesen, which is in Denver. They make charts, and And most of all the airlines use the Jeppesen product chart. So for the majority of what you're going to see in class, if it has to do with en route flying, like airways and things like that, we're going to use the government charts. But most of the SIDS and STARS and the instrument approach procedures that you see are going to be the Jeppesen charts. And that's kind of just to give you guys the familiarity of seeing both. But let me show you here. So if you are looking at Salt Lake City, one thing you can do is you can just simply go and type in Salt Lake City, up into this little thing up here, the box, and then you can just click on airport. Let's see here. Why it's doing that? So if it'll center you right on the airport, but if you zoom down into the airport, and I typically like to, when I'm on this, I usually like to be on the high chart. So I usually turn it on to the world high chart. It makes things a little bit more visible. So this is Salt Lake City here in the middle. So if you come into this and just right click, then you can actually click on, if you just hover over Salt Lake City, you can see over here it brings up this box of all of the instrument approach procedures. If you scroll down, it'll bring up all of your departure procedures, which are all your SIDS. Keep going down, and there's all of your stars below that. Now, if we wanted to look at that same one, the Jamin 5, just go to it, click on it, it's going to bring it up. If you want to expand it, just hit the arrows there. You can come down and zoom into it, but you can kind of see, more or less, that it looks a little bit different than the one we just looked at. So here's the Jeppesen version. And there's the government version. So you can kind of see there's your altitudes, there's your headings, there's your Milford VOR. Everything. You can kind of compare them. If you compare them side to side and look at it, if you ever have a chance, just look at them side by side and you can kind of see. But if you wanted to look at these, this is where they're at. Now, if you for the class, you'll never have a need to really look at these ones on SkyVector because we give you all of the Jeppesen charts in the Google Drive. So if you go to the Google Drive, let me clear that off of there. If you go into flight planning, Jeppesen charts, you can bring up any of this. These are all of the airports that we use in the class right here. If you come into Salt Lake City, which is the bottom right-hand corner, this is going to be the Jeppesen chart packet for Salt Lake City. And you can scroll through it. You'd have to scroll down to the bottom. Or let's see, not the bottom, but let's see. So it goes through the stars first. There's the Bear 4, Spain 6. So right here, you can see it says Jamin 4 arrival. Now, this one says 4. The other one that we were looking at said 5. All that means is that they have updated it, and now it's a 5. But in this class, we're just going to use it as the Jamin 4 arrival, just so you guys know. Whatever you see in this packet is what we're going to use. But you can see it's the same thing. Pretty much the same thing we're looking at. So if you want to, get looking at these to get familiar with them, that's where they're located. So once again, this is the government chart here. But yeah, you can get into all of them on SkyVector as well. So it has everything that you need on there. Any other questions on SIDS and STARS? Once again, just that basic understanding of what they are is really what you need to know for right now.
Okay.
Let's see here. Okay. So that's transition procedure. So when you hear us reference transition procedures, that is that's SIDS and stars. SIDS and stars are the transition procedures. Does anybody have questions on precision approach procedures or non-precision approach procedures, or what they are? Or does anybody want me to jump into one and take a look at it, go over it a little bit?
That would be cool.
Okay.
I agree.
Okay, let's do that. Okay, so just so everyone kind of understands what an approach procedure. So when we talk about approach procedures, we're typically talking this. So now, if you're thinking in terms of the actual flight, so at the end of a star, you can kind of see. Let me go back to this. So we're back looking at this Jamming star here, the one into Salt Lake City. You can kind of see that this is kind of where it ends. You know, like I said, you either turn and you land going this way, or ATC brings you up to the north, and then they turn you and bring you back down this way. Now, that's what you're ultimately going to do, but the way you do this is actually by following an instrument approach procedure, which is an instrument approach procedure is what these non-precision and precision approaches that we were just mentioning are. So depending on what type of approach you get assigned, it'll be either non-precision or a precision. Typically at a big airport, you're going to be assigned a precision approach. So we'll take a look at that first. Now remember, a precision approach is ultimately giving you lateral and vertical guidance. So up and down and left to right. So what we'll show you here is, let's go back out for a minute. So we're going to take a look at an ILS runway in Salt Lake City. We'll take a look at an ILS approach. Now, did you guys have a chance to look at these at all last night?
I reviewed some of them.
Okay. So there's a lot of information on this, and it's probably the first time you see these, and actually probably every time you see one of these, it's going to look confusing, and you're probably not going to make a lot of sense of it. Okay, that's totally normal. Every time I even bring one of these up, I look at it and I'm like, whoa, it's kind of like too much information. However, as far as a dispatcher is concerned, ultimately, as you become more experienced, you're going to be able to see all of this stuff. Like, you're going to be able to know what all of it is. So don't worry about like I said, this is another one of those things. Don't worry about trying to figure out what everything is. Some of it is pretty straightforward, but a lot of it is like really confusing. But for basic, at this point in your dispatch learning careers, there's only certain little things you need to know on this. So the biggest things that we look at, obviously we've got, we want to know what this is. So when we're looking at this, if you're looking up at the very top here, the header, we want to know what airport it's for, obviously. Salt Lake City, that's pretty straightforward. We can see that up there in the top left-hand corner. On the right side, Salt Lake City, Utah, and then the type of approach, ILS or localizer, runway 16 left. We want to know what kind of an approach it is and for what runway it's for. And that's obviously pretty straightforward. I imagine everyone understands that part of it. Everything up in this section up here, these are all your frequencies. Now, this is mostly just for the pilots. The dispatchers aren't going to care about any of this really ever. The only time you would ever even need to look at that or care about this is maybe if a pilot sent you a message and said, hey, what's the frequency for the ATIS or the Salt Lake City Tower? You could jump in here and you could say, oh, hey, it's for runway 16 right and 34 left, it's 132.65 or 119.05 for this runway or 118.3 for these runways. So anyway, those are just frequencies. Everything down here, this box here is so this is kind of the information for the approach. Now a lot of this stuff you're going to see this is kind of the text part of the approach procedure. There's a text part, and then there's a kind of the visual part, which you can see is going to be below here. But this is given some of the basic information for this approach. When we go through all the different navigation systems and stuff, you'll know that in the aircraft it has an ILS receiver, and if you are assigned an ILS this ILS approach, then if ATC basically says you're cleared to approach runway 16 left via ILS runway 16 left, that's usually the instruction that the pilots are going to be given. So the pilots, what they do is this is the frequency of the tuner for not the ATC frequency, but the actual tuner for the ILS receiver in the airplane. This is the final approach course, so that's the heading when they're actually flying towards the runway. It's going to be heading 164. This part right here is the glide slope intercept. So when we're talking about precision approaches, now these are the ones that have both the vertical and the horizontal guidance. So that receiver that you're tuning into in the airplane has the capability of telling you how far off course you are from a left to right perspective, the lateral perspective, and altitude-wise, how high up or down you need to be. So it's telling you that's where you get the precision. So it's giving you altitude and your horizontal positioning, essentially. So what this means, though, in this box is this is the point at which you intercept the glide slope. So everything, if when an aircraft starts using an ILS approach, ATC will descend them down to the 6,000 feet. And what happens is they'll have them turn to 164. They basically kind of guide them onto the approach, if that makes sense. But they'll have them turn, and then they'll have them, their final approach, they'll say turn heading 164, descend and maintain 6,000 feet. What happens then at this point is the plane, it turns to 164 degrees and it goes down to 6,000 feet, and it stays at 6,000 feet. It stays at 6,000 feet until it reaches this point right here, and this is that glide slope intercept point. Once it hits that point, it then begins a gradual descent down all the way until it lands on the runway. However, it's guided by the ILS system. So this YYIPP, that's an intersection or a point on the approach, which in this case it's called the glide slope intercept point. So that's what that's telling us. It's 6,000 feet mean sea level, 1,773 feet above ground level. So remember that. All these figures are given to us in sea level. Then the next box over is the ILS decision altitude. That basically means that as once the plane hits this glide slope intercept, it starts gradually descending down to the runway, and it'll take you all the way down to 200 feet above ground. So you can see 200 feet above ground would be 4,427 feet sea level, but then you can see right here, that's 200 feet AGL. So you're only 200 feet above the ground. That's the lowest point to which the ILS will allow the aircraft to come down. Now, ILS systems are typically used, for bad weather and things like that. However, it's not uncommon to use these on a day where it's completely clear, visibility 100 miles, no clouds. They still usually use the ILS even in great weather. But the reason why this becomes important to us is it's telling us how far down the ILS will actually allow them to come down. And in this case, for this approach, it's down to 200 feet. Now, if it were really bad weather and the ILS gives them this guidance down to 200 feet, once they get to that 200 feet point, they have to make a decision. Either they can see the runway and continue down and land. If they cannot see the runway, then they execute what's called a missed approach at that point. So that's kind of what this box is for. This is telling us that this is the decision altitude. So that's the point at which the pilot needs to make a decision. Either two options. He's going to decide to land, or he's going to decide to go missed. If he can see the runway, he'll usually land. If he cannot see the runway, he will go missed. But you cannot go any lower than 200 feet without being able to. If you cannot see the runway at that 200-foot point, you have to go missed. And that's as low as this approach will allow you to go down to. Does that kind of make sense to everybody so far? Once again, I'm going over all this stuff. I don't expect you to remember everything, but I just kind of wanted to give you an idea of what you're looking at here. But, like I said, this is going to be stuff that's going to be reviewed and repeated over and over as we do flight planning. So you will become familiar with ILS approaches and, the weather minimum. So this 200 foot becomes very important because, when we bring up weather and we start looking at weather later on, we need to be able to look at a forecast and see, if an airport is forecasting a ceiling of less than 200 feet, then that might affect us as far as, if their best ILS approach only allows us to go down to 200 feet and their forecast has a ceiling at our estimated time of arrival of less than that, then that means that when we get to that airport, we may not be able to land because there may not be an approach good enough or with low enough minimums. Now, that 200 feet is considered a minimum. And we'll use that term, we'll float that term around a lot throughout the course, weather minimums, especially when we're talking about weather later on. But that 200 feet becomes very important because not only is it the minimum decision altitude for this approach, but it also becomes the minimum that you need in your weather forecast in order to send a plane to this airport. So anyway, we'll talk a lot more about that later on, and there's a lot more that surrounds that topic. So then this next one over here is just simply the airport elevation. So you can see here, airport elevation is 4,227 feet above sea level. You can see back going over to that decision altitude, 4,427. So that's where you're getting your 200 feet. It's just 200 feet above the elevation of the airport. And then the touchdown zone elevation, of course, 4,227 as well. This box right here is the missed approach procedure. If you get down to that 200 feet and you do not see the runway, this is what you're supposed to do. You are then supposed to climb to 4,800 feet, then climb to 10,000 feet. And then it says inbound on the FFU, the Fairfield VOR radial 341. So we can take a look at that down here. But it's basically, so if you get down, you don't see the runway, the pilot needs to know what to do. So it just basically says, okay, I don't see the runway. We're going to execute a missed approach. So they throttle back up, and then they start climbing back up. They bring the landing gear up. They climb to 4,800 feet, and then climb to 10,000 feet, and then they have to find this 341 radial off the Fairfield VOR. I'm going to scroll down so you can kind of see where.
I have a question. Why wouldn't you go just straight to 10,000 feet if that's where you're going to end up anyways? It might have already been said, but why do you go to 48 and then go to 10,000 feet?
It's probably mostly because it has more to probably do with the Fairfield VOR. So what this means is, so just to kind of take a look at this just from this it'll make it make more sense here if you kind of watch this little part right here. So
okay.
So
sorry.
No, that's fine. It's a good question, but yeah, if you kind of watch this, it'll make sense. So this is looking at it from a top-down view. So let's pretend for a minute that, so this is obviously, if it's landing up, this is for runways 16 left. So that runway would be landing to the south. So that's, we'd be heading south essentially. So as the plane is flying, so this is, you can't see it obviously, but this is like following the star, like over here. And then this somewhere in this area would more or less kind of be the end of the star. And then ATC will have you turn over here, and they usually point you in the direction of this iron intersection, okay? So this is kind of where I was saying they transition you from the star over to the approach procedure. So now this is the approach procedure, which comes after the star. So the end of the star would more or less kind of be somewhere right here. ATC will say, okay, turn right, heading, they'll actually just give you the heading, but let's just say turn right heading 090, which is straight east. And then they'll usually tell you to intercept this would be the iron intersection. Or they also might turn you, and then they actually might turn you again, like heading this way. But they're usually going to give you some sort of an instruction to either turn to where you intercept this line here. This line basically represents the ILS approach system. So if you cross over this, your ILS receiver in the airplane will pick this up. And then eventually, if you're following it, if the ATC gives you the instruction that you're cleared to, cleared for the approach on runway 16 right, or 16 left in this case, that means your instruction is that you're, to pick up this receiver and start following this set of instructions now, following down this path. So this is the flight path that you would be following, coming down like this. This little arrow, if you can kind of see, this little part out here, this kind of looks like a big long feather. This is basically it just means that it's a glide slope, that there's a glide slope on this approach. So, but it usually means that there's precision guidance, meaning that it has the vertical and the horizontal. So anyway, you fly heading 164, heading down this path. You cross over the Toomey intersection, you cross over the Lagoon intersection. Anybody that's familiar with Salt Lake area would probably know why this is called the Lagoon intersection, because it passes right where the Lagoon amusement park is. Anyway, that's what you'll start seeing intersection names, and you'll kind of see why, they name them after landmarks. Anyway, so you keep going down this remember this YYIPP? This was the glide slope intercept. So once it hits this intersection here, now the plane is going to start descending. That's when it actually, because this whole time it's staying at 6,000 feet until it hits this intersection, and then it starts descending down until it gets, down to the 4,000, all the way down to 4,427 feet, which is 200 feet above ground. So it's following this, and if they get all the way down to the runway, which would be right somewhere in this area here, if they, like going back to what we were saying about, if they see the runway, they'll land. Once they get to the bottom of the glide slope, which is that 200-foot marker, if they can see the runway, they'll land. If they cannot see the runway, they go missed. Now, going back over to your question about the missed approach, so if you come over here now, you can kind of see the actual layout of this missed approach procedure. So the reason why it has those different set of instructions like climb to 4,800 feet and then climb to 10,000, the reason is because once you get to 4,800, you're not only continuing to climb to 10,000, but you're also turning, because even though it doesn't say turn here, this is where you have to turn onto that 341 radial. So the reason it's saying, because the first part of that climb, you're just going to still be flying the same exact direction. So if you come all the way down this, the instrument approach here, get all the way down, you don't see the runway, and then you do your missed approach, you actually just keep flying the same direction, and you climb heading that same direction to 4,800 feet. The reason why the 4,800 is significant is because once you get to 4,800, that's basically where you're now going to turn. Yeah,
Okay.
you're turning, and you're following the 341 radial down to the Fairfield VOR. So if you come into here, let's take a look at it from looking at it in here. So this is Salt Lake City here. So this is obviously a lot bigger. So this is the Fairfield VOR. So Salt Lake City's right here, but you would be flying straight down the approach, basically like this. That's the airport right where I'm at right now. If you go missed, you climb up to 4,800. You kind of continue on this path, but you see this right here, it's the 341 radial. So it still is technically basically a straight line. However, even though this chart doesn't depict it, there's probably a little bit of turning that's needed in here, because it's not going to be perfectly lined up with that 164 heading that you were on the approach originally. So as you come down, you climb to that 4,800, and then you intercept this radial, and then you follow that 341 radial into this VOR, and then it puts you into a circular pattern down here. So, and then ATC will give you further instruction, but that's basically, if you don't land, those are your instructions. You continue down to this Fairfield VOR, and then it just has you circle. So if I go back to the chart here for a second, see how it has this circular, these arrows that go in a circle here?
Mm-hmm.
That's just your common holding pattern is what that is. It's just basically, you're just putting you into a standard holding pattern, which you don't necessarily need to understand everything about that, but it's just basically you're circling over the top of that VOR is ultimately what you're doing, waiting for further instruction from air traffic control.
Okay.
So anyway.
Cool. Thank you.
That is what the approach. So now below this, you see the actual profile view of it now. This is looking at it from the side. Now, it's only showing the portion from this iron intersection down to the missed approach point. So if you're looking at it, now this is looking at it, like I said, from a cross section, I should say, the same way. So over here, you intercept that iron intersection, so you can kind of see you're flying down, you get down to 9,000 feet, you level off, and then you descend down to 7,500 feet, level off, go hit through the lagoon intersection. So it's kind of a step down. You kind of see you start out at 11,000, now you 9,000, 7,500, and then from there you go down to 6,000 feet, which is that final altitude which you level off at. And then once you hit here, that's the glide slope intercept. Now you can see how it steps down all of these, but once it gets here, you can see it's just a straight line, straight angle all the way down. That's that point at which the plane starts going on that 3-degree glide slope straight down. So if you're wondering what the descent angle is, you can actually see it over here. Glide slope is 3 degrees. So it's just basically, you have the plane just it's just basically going down at a 3-degree slope rate, following it all the way down to 200 feet. And down here, it's that missed approach point, and you either continue and land or you go missed out this way. So this is just showing from the cross-section point of view here, though. Excuse me. Okay. Any questions on that? Yeah.
Yeah, Adam, I guess your question, or she mentioned about why go up to 10,000 when you're only needing to be at 6,000 on the final approach, and I could just add some texture to that. Back in the day, a long time ago, this is the area I operated in, and what it isn't showing on this template here is that 10,000, Class B airspace in Salt Lake, you have, of course, that cake. And underneath that cake, you have that Hill Air Force Base traffic. So you've got fighter jets traveling in twos, shooting in and out of there. And then on the other side of it, you have Ogden Air. And then putting them in the holding pattern kind of gets them out of those precision approaches, not only to Salt Lake, but other traffic.
Yeah, that's correct. Yeah, and in this case, yeah, and specifically talking about the missed approach. If you see the beginning of this, so this approach starts at 11,000 feet over here. That 11,000 foot point is up here at this iron intersection. So that's 11,000 feet. So now if you end up going down the approach, but you can't land for whatever reason, you go missed, you basically, it's having you climb back around. And kind of like Greg's saying, there's a lot of other traffic and terrain in this area. But you've got Hill Air Force, you've got all sorts of other things going on. But the one thing about an instrument flight planning is that when you're on an IFR flight plan, your ATC provides all your spacing. You have sets of instructions, whether they be on a chart or whether they be from ATC, but it's giving you that separation from other traffic or other things in the area without being able to see them. So like Greg's saying, there's a lot of other things going on here. You've got all these mountains over here that you can see the elevations here, 9381, 9223, 9679. You got mountains up to 10,000 feet, basically all right there. You have Hill Air Force Base, which is right here, right at the very beginning of the approach. You got Hill Air Force Base right there. You're above it. So there are a lot of other things. And one other thing too is, if going back up here to this this top part, this little box here, I failed to mention, but this little box here is called your MSA, which MSA stands for Minimum Sector Altitude. And what this means is these altitudes that are in this circle here represent the highest either terrain or obstacle clearance in the area. So this circle, so if you can pretend where I put that yellow dot in the middle of the circle, that dot represents the airport. So this has a 25 nautical mile radius around the airport. That's what this circle represents, is a 25 nautical mile radius. So if you are to the south of the airport, the minimum obstacle or terrain clearance for that area is 12,700 feet. If you are to the north and east of the airport, it's 11,000 feet. If you are to the north and west, it's 8,600 feet. So this is what this is telling you here. If you if you know that you just came down the approach and you are flying south and you ended up going on a missed approach, well, now you are south of the airport. So if you want to be guaranteed to not hit anything, then you need to be above 12,700 feet. Is basically what it's saying. So that's another thing to look at. If for some reason now this box, now like I said, ATC normally gives you the instructions and the spacing that you need to begin with. However, if you were to lose communication with ATC, let's say your radios go out and you don't have that communication, and let's say you have an electrical failure in the plane or some other thing go wrong where you don't have either communication availability, or let's say your VOR receivers or something else goes out where not only can you not communicate, but you also can't see where you're at. Well, you probably need to know at least the minimum altitude that you're going to want to be at to clear all obstacles, especially if you don't have an idea where you're at and you can't talk to anybody. So it's kind of more for an emergency purpose here, but if you lose your communication capability, then this is one of the first things you look at, because you need to be at or above this altitude in order to clear all obstacles, at least until you can get communication back or figure something else out. So that is what that is for there. So yeah, there's a lot of stuff on these. Obviously, like I said, a lot of information. Down here at the bottom, this is just telling us the speeds that you need to fly out, which isn't too important for you guys as dispatchers. This is once again, this is the missed approach procedure, but it's kind of listed in a different format. Climb to 4,800, then climb to 10,000 on their 341 radial again. And then everything below this is is the weather minimum category. So down here, this ILS, you need a 2. This is, and we'll go over this a lot more later, but this is referring back to that 200 feet that you can go down to. That's the lowest you can go down to, 200 feet. And then the visibility minimum is either RVR 1,800 feet or half mile. Now that'll become a lot more familiar once we start going through weather. But you're going to look at this a lot. But typically the number one thing that dispatchers look at on this entire chart is usually going to be this bottom box. That 99% of the time when you're looking at one of these procedures, you're looking for the weather information, that and that. And like I said, you're going to see this hundreds of times in this class. So don't worry too much about it now, but just wanted to get you a little bit familiar with what we're looking at. So let's see. Sometimes I kind of buzz right along without taking breaks. So probably good opportunity now let's take a break. It's basically 7 o'clock. Let's take 15 minutes. Just be back 7:15. Does that work for everybody?
Yep.
That's perfect.
Okay. Okay, so let's see here. So obviously we kind of just got done looking at a precision approach. Whether you're looking at a non-precision or a precision approach, they're basically, the chart layout and everything else is pretty similar. Going back earlier to what we were saying about the differences between, let me turn this back on so you guys can see the differences between the different types of charts. So like, once again, this is a Jeppesen chart. In this class, all of the instrument approaches that you guys look at, all of these types of charts will always be Jeppesen. So you don't really need to worry too much about seeing the other ones unless you want to just look at it and compare the differences. But the best thing is to not really worry too much about confusing yourself between the two different types of charts. I mean, they're essentially the same, but like I was saying earlier, for all of the stuff that we do in this class and later on when you have your dispatch licenses and work for an airline, you're going to be using Jeppesen charts at any airline you go work for. So that's what we like to use in the class. So unless you just want to get kind of see the differences, you can bring the other ones up on SkyVector, kind of like I showed you earlier. You do it in the same way you brought up the transition procedures. There's the approaches are just right in that same area as well. But yeah, so you're always going to use the Jeppesen charts for your transitions, your SIDs, your stars, any of your approaches, whether it's a non-precision or a precision, any of that stuff. And then any of the en route stuff, we use the actual government charts for. That's what SkyVector is. It's just it's an overlay of the government charts. So when you take your actual practical, or when you do any of the flight planning in this class, you will use it'll be the same way. And in your practical test with the actual examiner at the end, it'll be the same. You'll use the government charts. The paper charts are the government ones, but then you'll have the Jeppesen charts for everything else. You'll have access to any of the paper charts or whatever you need for your actual practical test. So anybody can think of any questions that they have on instrument approaches, precision, non-precision, anything there. So the only difference here is if this were a non-precision approach, you just wouldn't, the only difference is you wouldn't have this little section right here. So if you kind of look at this from this point on right here, this little section, this is the beginning of the precision part of the approach. It's kind of where that feather, once again, where the feather starts, and you start that glide slope down. If this were a non-precision approach, you wouldn't have this glide slope in here. All you would do, and I'll show you an example of one so you can see, but you would just continue, kind of like you see in this part where it steps down. You would actually just keep doing that same method. You would just step down, step down, step down, all the way, instead of picking up this glide slope where it actually just has you maintain a steady descent angle. You would just descend down to whatever altitude. Now, if you were to look at this, actually on this same approach, when we were looking at this back here up at the top, if you remember, this approach is an ILS or a localizer. Now, an ILS is a precision approach. A localizer is a non-precision approach. So if you are using the localizer part of this approach, you actually come down to here. And if you see this over here, so this side, this left side is the ILS side. The right side is the localizer side. So that basically means what the localizer means is that you're not using the glide slope. You can see right here, glide slope out. Now, there could be various reasons that you do this. The primary reason would be is if the glide slope wasn't working. That makes this approach into a non-precision approach. If that were the case, the minimums for this approach then become this 453 right here. Does anybody remember what we do with this number here when we see anything in between like this, like where it's 453?
What is the next number?
Yeah, we got to round that up. So what does this 453 mean for us if we're flying this approach without the glide slope? What's that, Matt? I can't hear you, Matt.
That's your decision there, right?
Yeah, but what is the decision height? It's 500, right?
Yeah.
Okay. Yeah, so this, even if that said 401, you got to round that up. And does anybody know the reason for that?
That's just what I was going to ask. I don't know why you have to round up if you're only one number off of 400. It's 401. I mean, it might as well be 400.
I think they're erring on the side of higher than lower when you're a non-precision.
Correct. Well, the big thing is it is not possible for your altimeter to read 453. So your altimeter is only going to read in hundreds of feet. So you even if it said 401, you could never actually see 401. You can only see 400 or 500. So if it was 401 and you were waiting till 400, technically at that point you would be below the legal minimum for that approach. So yeah, that's the reason though, is that it really just comes down to the altimeter. Is it's not possible to read anything outside of the every 100 feet on an altimeter. So yeah, so we got to round those up. So yeah, so if the non-precision part of this approach, if you don't have the full ILS glide slope, then you can only descend down to 500 feet, and then you have to make that same decision. Can I see the runway at 500 feet? Yes, no. If yes, land or continue. And if not, then you do that missed approach procedure. Let me bring up let's bring up one real quick here though. Let's see. Of course, Salt Lake doesn't have any, so let's take a look. St. George here for a minute. I can't remember if St. George has DME. Now they have this GPS approach here. Let me look at one that's better. Let's look at Ogden. Okay. So now this is what a non-precision approach will look like. So you kind of see what I was saying earlier. You just descend down and you descend down to that final altitude and you just level off. So anyway, that's the only real difference, is you don't have that vertical guidance. So the approach on this runway here, you can go down to 452, which once again, that means 500 to us. And then this is your visibility depending on the category of aircraft you're flying. Can everybody hear me okay?
Yeah, loud and clear.
Okay.
Yes, sir.
My reason I'm asking is because it's giving me an error saying that my audio quality might be degraded for some reason. So just wanted to make sure. Okay.
Oh no, you're good.
Alrighty. Okay. So any other questions on approach procedures?
No, sir.
Okay. Alrighty. Well, we're going to jump in to this communication stuff here. A lot of this stuff can be covered fairly quickly, so I'm not too worried about, most of the stuff is pretty quick, but maybe what might serve us a little bit better is now, since this is kind of technically the end of the navigation portion and switching over to communications, you guys want to do a quick review on what to expect quiz-wise for the navigation portion?
Yes, please.
Okay, let's do that. I'm going to bring up some questions. I'm going to turn off my screen here for a minute. Let's see here. Okay. So let's just kind of go around here a little bit. If you guys want to kind of chime in. Somebody name, let's see here. Can somebody name 3 different types of satellite-based navigation?
NDB, VOR,
So of satellite navigation, satellite-based navigation.
GNSS. Is that
Yeah, that's one.
Do you say JMSS?
G? Golf.
Oh, I'm sorry.
Also GPS and WAS and LAS.
Yep. Yeah, GPS, WAS, WAAS. That's another one. Yeah, so there's 3 or 4 right there. So you'll need to be able to name 3 different types of satellite-based navigation on the quiz. Somebody want to name 3 different types of ground-based navigation.
VOR, ADF, NDB, DME, I'm sorry.
Yep. VOR, ILS, NDB, VOR, or VORTAC, DME, localizer, ADF also is one. Anybody have any others that they're curious about? Obviously, that's 4 or 5 right there. You need to be able to name 3 of them for the quiz, though.
VOR, what else?
VOR, ILS, NDB, VORTAC, DME, localizer.
LOC.
What's that?
Localizer is just the LOC, right?
Yeah. Okay, you need to be able to name or explain what a SID route is. You know, the actual definition. Anybody know that? Again, I know we covered it earlier.
SID is the I wrote down the standard instrument departure. When you're in a high traffic airport, it's something that ATC assigns. It's like your path to your airway or your jet route to your destination.
Yep. How about a star?
For landing,
just
it's
wanna-
the opposite.
Sorry.
Oh, sorry.
You're just wanting to know what SID and STAR definition is and what they do, or
Yeah, well, you need to be able to do both. I need to know exactly what does STAR stand for and what the purpose of it is on both SIDs and STARs. So SID,
What does STAR stand for?
STAR, does anybody know what STAR stands for?
I don't know the T, but
Standard terminal arrival route.
Yeah, standard terminal arrival route. Then the purpose of SIDS and stars is going to be the biggest purpose, kind of like we were mentioning earlier, is to reduce.
Cut down on ATC and pilot workload.
Correct. Yep. Cut down on the ATC pilot workload. And yeah, the true definition is, I mean, that'll work. That's the biggest purpose of them. But yeah, they are to deconflict potentially conflicting traffic by the use of specific routing levels, speed restrictions, and checkpoints. Now you don't have to necessarily say it like that, but yeah, I mean, the big takeaway, biggest purpose, reduce workload between pilots and ATC.
Sweet.
Need to be able to name 3 different types of non-precision approaches.
I'm trying to phone the handset. I can't write as fast as everyone's talking. So I'm just gonna name the SID and stars definition and what it means, and then the term the biggest purpose is to cut down on what?
Pilot and ATC workload.
And what was the question for that?
What was that question you said?
Yeah.
It's just, what is the purpose of SIDS and stars?
Okay. Thank you.
So yeah, we need to be able to name 3 different types of non-precision approaches and 2 different types of precision approaches. Does anybody want to spout off 3 different non-precisions?
I have LOC, VOR, GPS, and NDB.
That would work. Anybody want to name 2 different types of precision approaches?
ILS and GPS.
ILS, and what was the other one you said?
RNAV or GPS.
So RNAV and GPS would technically both be considered non-precision.
Oh, okay. So then I have PAR.
PAR would be one, yeah. It's uncommon, but it is one. ILS, PAR. You could do
MLS,
MLS was one, yeah. TLS,
RNP,
RNP,
TLS.
yep. You need to be able to state what the difference is between a non-precision and a precision approach.
And that's just that one's only horizontal and one does vertical and horizontal.
Correct, yeah. So a non-precision is going to be horizontal only, and a precision is both vertical and horizontal.
Cool.
Let me look at something else here. Okay.
Okay, so state the difference between non-precision and precision. Non-precision is horizontal only, and precision approaches are vertical and horizontal.
Correct.
Okay. Can I word it like that, or does that have to be more words to
No,
specify?
that would work just fine.
Okay.
Okay. Yeah, that should be pretty much it for the questions on navigation stuff.
So he's not going to ask about airspace and stuff like that.
Yeah, that's just the navigation
Oh,
part.
I'm sorry.
Yeah, I'm bringing up the other one. 1 second. Okay. Can somebody tell me what RVSM stands for?
Reduced vertical separation.
Correct. Yep, reduced vertical separation minima. Yep. And what flight levels are associated with RVSM?
Can you repeat the question?
Yeah, what flight levels are associated with RVSM airspace? Did you guys go over that?
Yeah, we did.
Anybody have a guess?
I think I found it. Is it FL 290 to FL 410?
Yeah, so flight level 290, which is 29,000 feet. So flight level 290, so that's where it starts, and it goes up to flight level 410, or 41,000 feet. So 290 to 410, which is 29,000 feet to 41,000 feet. And can anybody tell me what specifically is what's being reduced in that airspace? Like what is the criteria for that?
Reduces turbulence and wind damage.
Well, I guess what I'm saying is what's the difference between RVSM airspace and other normal airspace?
RVSM airspace is a separation of 1,000 feet, so you can fit more airplanes in.
Yeah, so typically airplanes are going to be separated by 2,000 feet in most areas, right? So anything that's not RVSM airspace, you have to have 2,000 feet of separation between your airplanes. When you go into RVSM, you only have to be 1,000 feet separated. So it doubles the amount of airspace that becomes usable.
Okay, so you said that the difference between RVSM and normal airspace is for RVSM you have to be at least 2,000 feet separated. What?
So RVSM is only 1,000 feet. If you're in RVSM, you only have to have 1,000 feet of separation. All other airspace, you have to have 2,000 feet. So I shouldn't say all other airspace, but when you're above 18,000 feet, you have to have 2,000 feet of separation. But that
What-
part that part doesn't. I don't want to confuse you with that part. Just the big thing is RVSM means you can go down to 1,000 feet of separation. That's really what I want you to know here.
What situation would you be able to use that in? Like when would that qualify?
Well, if you're up flying, if you're between the flight level 290 and 410, then the minimums of separation are just reduced. So anytime you are flying between 29,000
anytime.
feet, yeah, anytime. Yeah, if you are
Oh, okay.
if you're in that space between 29,000 and 41,000, then there is only 1,000 feet of separation. But that's always.
Hey, Adam.
Yeah.
If your airplane isn't RVSM qualified, are you not allowed to go above 29,000 feet, or did they just move the other planes around to like accommodate you?
That's correct. So if your aircraft is not RVSM capable, you cannot go into RVSM airspace. Now there are several things that and we'll talk about that in systems later specifically, but there are certain criteria that the plane does have to have in order to be RVSM capable. But that stuff we'll cover later. But yeah, you're right. If it doesn't have those things, then you cannot go into RVSM. You have to stay below 29,000. Okay. Can somebody name 3 different types of airways that we see on navigational charts?
Are you talking about like the vector airways and?
Yeah, just those. Yeah, there's basically 3 different types of airways. Can somebody name them?
It'd be Victor, Juliet, and Quebec.
Yeah, so jet routes, Victor routes, and the Q routes.
Q routes, that's what I didn't have.
Do we have to say jet routes, or can we just say QJV?
You can put J route, Q route, and V routes, but if you ever refer to them, it is jet route, Victor route, and Q routes. But yeah, if you're writing it down on the quiz, a J route would be fine.
Jet and Juliet are the same thing.
Yeah, but I don't refer to it as Juliet though, because nobody will know what you're talking about there.
Okay.
So what is the Q stand for besides Quebec, or is it just Quebec?
Well, people just say Q, but yeah, I mean, if you were, I mean, you could say Quebec, but when people refer to it, they always just say Q route. So there's no rhyme or reason, like why they say jet for that one and Victor, but then they only say just Q for this one. It's just probably more of just how it's evolved, over time. But
It's just the way it is.
yep. Not the end. Yeah, it's not like you would get it wrong if you said Quebec route specifically. It's just that if you were using that terminology like in the real world dispatch, you would get looked at kind of funny. That's all. And then let's see. Last question here. What class of airspace are most major airports located in?
Bravo.
Correct. Class Bravo.
missed the question, Adam. What was it?
What class of airspace are most major airports located in?
And that's class B.
Yep, B as in Bravo. Okay. Everybody get it all?
Yeah. I did.
Okay. Good deal. Let's see here. Okay, so we're going to start talking about communication stuff now. Unless anybody has any last minute questions on navigation.
Actually, I got one more question. I guess I thought I had it, but I don't. So, define SID and define star.
Yeah, so that one, what's that?
So yeah, I have the standard instrument departure and standard terminal arrival route, but I don't have the define part.
Well, that's the purpose that we talked about earlier.
Okay.
You wrote that down, right?
Oh, yes, I did.
Okay.
And then Adam, Garrett had mentioned something about us memorizing the different lighting systems. Is that going to be on our quiz too?
The lighting
Or is that
systems?
all the different lighting systems
Like approach light systems or?
approach light systems
No, yeah, that's,
for later.
yeah, we would, yeah, look at that later. So
Okay.
shouldn't be anything you need for this one.
And also I have 3 different types of non-precisions.
Yes, so we went over that one. So off the top of your head, Matt, do you remember any?
Wouldn't it be I can't remember.
Okay, because I thought you were the one who answered it earlier. That's why I was. So let's see. So for non-precision approaches, that's what you're looking at. So you remember what a non-precision approach is, correct?
Non-precision approach is basically just, oh, wait a minute. I think I got it. It would be localizer, VOR, NDB, GPS, all that.
Yep.
Oh, okay. Okay.
Okay. Any other questions on anything about navigation?
I'm sure I got everything down now.
Okay, good deal. Let's see here. Okay, so we're going to start talking about communications. And let's see. Let me bring this up. So going back into the FARs here for a minute, okay? So we need to know, well, as we start our talk about communications here, the first thing we need to know is what the regulatory requirement is for communication regarding a Part 121 flight. Now, don't want to dive obviously too far back into the FARs again here. I know everyone's kind of sick and tired of those. However,
We love them.
Oh, I know, and you'll do nothing but just grow to love them even more over the years. So, does everyone first off remember the different types of operation as far as the FARs are concerned? Like if I am flying a scheduled passenger flight, what part, what FAR section am I operating underneath?
Part 121, right?
Correct. Yeah, it's Part 121. So, Part 121 is going to be the FARs that explain to us the requirements for operating a 121 flight. Okay, so the very first thing we want to look at with regards to communication is what do the FARs tell us that we need to have in order to conduct a Part 121 flight. Okay, so let's just review that here just really quick. Let me scroll down to this here. Bear with me for just a minute.
Is it in regards to having like two types of communications?
Yeah, it is.
Okay.
So yeah, and I'm just bringing up. Yeah, I'm not asking anybody to answer it yet. I'm just I'm getting to the FAR so we can read it. Okay. Okay, so let's go to. So FAR 121.99. I'm going to zoom in onto this here. Can everybody see that good? So this is telling us here that each certificate holder, that just basically means airline in our case, each certificate holder conducting domestic or flag operations must show that a two-way communication system or other means of communication approved by the FAA, the FAA Certificate Holding District Office, is available over the entire route. The communications may be direct links or via an approved communication link that will provide reliable and rapid communications under normal operating conditions between each airplane and the appropriate dispatch office, and between each airplane and the appropriate air traffic control unit. Okay, so just reading that through that first paragraph, first of all, it's telling us, just to kind of sum this up, in order to operate a 121 flight, the FAA is telling us that we need to have constant two-way communication available to us at all times over the entire route, and that it needs to be reliable and rapid. Now, it doesn't say this in the FAR specifically, but just if you guys were just to take a guess, what do you think reliable and rapid means? Like for instance, like what do you think they're trying to get across here in this FAR specifically by saying that the communication link that we use needs to be reliable and rapid? Anybody want to take a stab? And just even a guess, because I don't expect anybody obviously to know this because it doesn't say it here, but
I would think reliable means something that's not cutting in and out or dropping coverages or operates during certain hours only, that kind of thing. And rapid, of course, if you're needing to, like it mentions in dispatch communication as well, I mean, they're going to be pulling emergency procedures if they can't get a hold of you ASAP. So.
Exactly. Yep. Yeah. So we need to be able to show, the reliable and rapid. Yeah. Obviously, you hit it right on. So reliable meaning that it can't be something that it needs to be constantly working and not prone to failure. And rapid means that, if ATC talks to them, there needs to be a rapid response. They can't go all this time without, not responding. Obviously, it's going to send off a lot of, alarms if they don't start responding. So it needs to be rapid communication. Now, when you talk about rapid communication, it's going to be a little bit different. Obviously, with ATC, the response pretty much needs to be immediate. If ATC says something to you, that communication back needs to be immediate. Now, let's say the dispatcher wants to talk to the crew. What do you think the FAA expects as far as now, if the dispatcher, I know you guys have talked a little bit about ACARS messaging. It's like a text message, right? You send it to the airplane. That's pretty much how most dispatchers and their crews communicate, is through ACARS messages. If you're the dispatcher and you send your crew a message, what do you think that the response time from an ACARS message should be that would still fall under rapid? Obviously, it's not going to be as fast as ATC, but what do you think the expectation would be?
I would say a couple minutes.
Yeah. So just to let you guys know what the FAA thinks. The FAA considers anything, it should be 4 minutes or less would be considered rapid. So basically, though, I mean, to sum this all up, we can't operate a 121 flight unless we have reliable and rapid communication available to us at all times over the entire route to be flown, and having it at our disposal. So if we send them a message, they need to be able to respond within 4 minutes. If ATC talks to them, they need to be able to immediately respond. So, and it's not just ACARS messages. Obviously, we can pick up the phone. We can call them on the radio there. We can call ATC, who can also get a hold of them. But the two-way communication needs to exist over the entire route to be flown. If at any time that does not exist, the flight is no longer legal to continue. So that's what you guys need to understand from a regulatory standpoint regarding communication. Okay, let's read on a little bit here. It says, except in an emergency, for all flag and domestic kinds of operations, the communication systems between each airplane and the dispatch office must be independent of any system operated by the United States. that's basically telling us that the system that the dispatch office uses, like the ACARS system in this case, mostly, it has to be different than like the United States. When it says the United States, they're talking about the air traffic control system. So it has to be independent of ATC, is what it means there. And what happen? Once you're a dispatcher, you'll see this a lot too. Is a lot of times we get phone calls from air traffic control telling us or asking us to get in touch with our flight because they can't get in touch with them. Now, let me tell you something very, very common that happens. In fact, when I was working at SkyWest, this would happen probably, and now considering the scope of the operation, SkyWest operates between 2,000 and 2,500 flights a day. But this would happen probably, I don't know, 10 to 15 times at least. 10 to 15 times at least per day. ATC calls the office, and they have the number that just calls directly to the OCC shift manager, the guy who's over the entire room, essentially. When they call, it goes straight to that desk. That guy answers, and ATC says, hey, you have your flight SkyWest 5220, and we can't get in touch with them. So basically what they're calling to ask you to send him a message telling him what frequency they need him to be on because they can't get a hold of him. So this is why they're telling us that our systems need to be independent, because a lot of times they need us to contact our flight. And sometimes, they actually need us more than we need them, usually. So, but like what's very common is that they will be flying, and let's say that ATC, was handing them off to a different control center. They would basically say, SkyWest 5220, contact Salt Lake Center on 132.7. But what happens sometimes is the pilots either mishear, they didn't hear it correctly, or they didn't verify it, and sometimes even just kind of a slip of their fingers, and they accidentally go to a different frequency. And then they kind of get lost in the shuffle. They don't end up remembering where they were supposed to be or what frequency they were on. And so they kind of get lost, and sometimes they don't even know it. They're having a conversation in the cockpit, not realizing that they're on the wrong frequency or that they accidentally dialed in the wrong one. And then they're not talking to anybody. And then, of course, ATC is trying to get a hold of them. They can't. And so they called the dispatch office to have the dispatcher send them an ACARS message, because it doesn't matter what frequency they are on for the ACARS, your message is going to go to the plane. They can't dial in the wrong frequency on that. So that's pre-programmed, preset. So they know that the ACARS message will arrive, but they don't necessarily, they have no other way of getting a hold of them other than the dispatcher at that point. And that happens, like I said, probably, 10 to 20 times a day at least.
Adam, I think that sounds like, geez, that pilot must not be paying attention. But if you have ever been in that situation in kind of a Class B and hear all of the radio chatter, it's like being in a noisy dance hall and listening for specific instructions to you. It's a lot of information going out, and I can see how easily that could happen.
Oh yeah, absolutely, and I totally agree. And when you go jump seating, you will see it. I've seen it several times sitting in the jump seat, and I've probably been the cause of some of these, because I've been the one in the jump seat sitting there, having a chatting away, and having some side conversation, and meanwhile, I maybe was talking when ATC was trying to get a hold of them. You'll end up realizing, and learning that there's obviously kind of a code of conduct when you're a jump seater. that you're supposed to abide by, and you're supposed to stop talking if you hear ATC chiming in on anything, and you're supposed to wear a headset normally so that you can hear ATC. So yeah, I mean, but that happens all the time, and like I said, I've personally witnessed it, and I don't fault the pilots one bit, because I think it's amazing that even when they're actively listening, that they can even pick up their own call sign between all the chatter going on, because there's so many call signs out there that are alike, especially if they're in an airspace like in SkyWest's example. If they're flying in and around Salt Lake, the majority of the call signs are going to be SkyWest, and then you got to listen for your 4-digit flight number behind that, and so many of the flight numbers are so similar that it's very, very easily to get confused and get the wrong plane's transmission, this and that. All of a sudden, you're on the wrong frequency, and like I said, it happens at least 10 to 20 times a day with SkyWest operation.
On top of that, once you know they're talking to you, no offense to ATC, or FAA in general, like tower communication, they talk like they're selling meat in Texas. I mean, they talk so fast that you better have an incredible oral memory, and you're also, you're asking, say again. I mean, and then by the way, you've got rain and, minimums, and you're trying to navigate the airplane and bouncing around and watching for traffic. I mean, there's a lot going on.
Oh yeah, absolutely there is. And yeah, I mean, going back to our conversation about the SIDS and stars, just another reason why, they're trying to implement, processes and procedures to reduce that workload, because it is tough, and it's tough they do get talking you got to learn the lingo fast, because yeah, it's like I said, sitting in the jump seat, I'm amazed at the fact that they can even pick up the instructions, let alone their own flight numbers amidst all the chatter. It really is kind of one of those things that you have to get just develop an ear for, and just kind of get used to.
I'm actually stunned that it's only that many times. I mean, it's considering the number of flights. That's crazy. That's actually pretty good.
Yeah, I think I'm probably being conservative, but yeah, I mean. But going back to this, that is the reason why our system has to be independent of the ATC system. So we have to get it. We send ACARS messages, like I said, all day long, that are like, hey, Denver Center looking for you guys on this frequency, and then they message back, hey, thanks, So it happens all day long, every day, and that's just SkyWest. I mean, you can imagine all the other ones out there. Let's see here. So Matt messaged a question. Let's see here. Just reading your question here, Matt. 1 second. So if a pilot finds himself not talking to ATC, Yeah. So Matt asked if a crew gets switched to another frequency, but they accidentally go to the wrong one, could they not just go back to the one that they were most previously on and ask them again what frequency? Yes, and that is the standard operating procedure. That is what they're supposed to do. They are in. So they normally have 2 radios that they're working in a 121 flight. The one radio goes to the is the one that changes over to the frequency they're supposed to be on, and the previous one always stays on the channel prior, or the frequency that they were last on, so that they can just go over to the other radio and go back. However, and normally that is the procedure, they'll just go back and ask them. However, in this case, the situation with this is that if they end up doing something unknowingly, then they don't even know they're on the wrong frequency in the first place. So if they don't even know that, then they're not going to know to go back and ask. So that's the only time that this happens is, like I said, it's still pretty frequent, but it's only cases where they're not even, they're not, it's common to go, really long without getting even an ATC, depending on where you're flying, what time of day. You might not hear any ATC chatter at all. And if you're up at cruise altitude, if you're having a conversation and they're in the cockpit, it might be the last thing on your mind. So just the fact that you haven't heard from ATC for a while isn't always going to ring a bell. So, but yeah, if they do know that they might be on the wrong frequency, then yes, they should always go back to the prior frequency and ask. But the situation in this case is typically they don't even know that they're on the wrong one in the first place. So, let's see here. So this is what the FAR is saying as far as the reliable and rapid communications that we need to have. It goes on to talk about like international flights, ETOPS flights, and things like that, and what you have to have like when you're flying over the ocean and things like that. We're not going to get into that. It's part of it, but but just to give you guys an example. So I now work for the FAA. I just got done doing an inspection earlier this week of this specific FAR here for the UPS airline operation. So I kind of during this inspection, I had to sit with a dispatcher, and part of the process was that I asked the dispatcher to I just pick a flight from, whatever ones he has in the air, and I say, send this guy a message, and, our goal here is to see how quickly he responds. And I'm watching it from an FAA, regulatory standpoint. And if it takes really anything more than 5 minutes, we're not like a stickler, like it's right at the 4-minute mark. But if it takes really over 5-6 minutes, then that's something we're normally going to document as a negative finding for the airline. So the other problem here as well is when a crew. So it goes both ways. So if a dispatcher sends them a message, the plane needs to respond usually within 4 to 5 minutes to be considered reliable and rapid. If the crew sends the dispatcher a message, it's the same. Should be always responded to within 4 to 5 minutes. So we watch it both ways. But that's also for when you guys are dispatching later on. You're gonna, and this happens in every dispatch office. So you're gonna have those dispatchers that like to kind of get up and socialize and things like that. And meanwhile, they've got an ACARS or two, roll in, and they're not even at their desk. And, lo and behold, 10 minutes later, they decide to go back and check things, and, it's been 10 minutes, 15 minutes since the messages were sent, So you need to watch out for that kind of stuff because it's a big no-no from the FAA standpoint. So if you're ever getting up and stepping away from your desk, you always need to have another dispatcher watching your communications and watching your flights for you. So obviously, we get up, we got to go to the bathroom, we go eat, we do all that stuff. But just whenever you do that, dispatchers don't have scheduled breaks or, lunch or anything like that. You have to be able to fit it in. Not to say that you don't get them. I mean, you obviously get them, but you have to, anytime you step away from your desk, you need to arrange to have somebody else that has a dispatch license to watch your flights while you're not there, so that this can be complied with, if that makes sense.
It's just so nice, Adam, just coming from the, the private pilot VFR side long ago to this side, knowing someone's always on your shoulder, just helping you along the way and having that direct line ACARS right there for you is just, wow, that's huge.
Yeah, no, absolutely. It really is. It's kind of funny when you start looking like the more you'll get to know a lot of pilots, obviously, as you dispatch, but you'll start to realize that there's been a cultural shift in pilot thinking. Like a lot of the older pilots like that are still flying nowadays kind of date back to like, coming up through the military and things like that. But they have their old school ways, back when dispatchers didn't, weren't necessary or didn't exist. They're not used to having dispatchers, nor do they even like them, like having them nowadays. They kind of just want to have that complete control, don't think they're necessary. But then you have some of the other ones that have learned to, to utilize the dispatcher and find out how much of a convenience it is. And there's a pretty big, stark difference between kind of that shift of more recent pilots that have come up through the years always having a dispatcher, and those that haven't over the years that are kind of towards the end of their careers. So you'll get some different, pretty different opinions overall. But yeah, obviously the FAA and just from an aviation safety standpoint in general, it's dispatchers can play a huge role, and you'll start to realize they make a lot of the emergency type decisions. If everything's going good and everything's going, as planned, the job's pretty easy as a dispatcher. The tough days are really, when there's a lot of weather, when you have mechanical emergencies and medical emergencies, and you'll usually see some of that every day. But, if you dispatch 50 flights on a given day, or on a given shift, you're only going to have usually at most, even on a bad day, 10 to 15% of your flights that might have issues where you have to do a lot of extra work. The majority of your flights will always go off without a hitch, as planned. Some of them you don't ever even talk to, it's really the ones that, it's just those one or two, or it's like the 5%, that just either have issues or have mechanical problems or some other sort of issue or emergency or weather or something going on that cause you the work, the ones that you really got to work for. So,
I imagine also how well you set it up. If you take a lot of time and do it right, then you're going to have far fewer problems later on.
Yeah, exactly. Yeah. So, and we'll obviously talk a lot about that stuff over the next few weeks as well. But yeah, so this is what the FAA requires as far as communications go. You always have to have that reliable two-way radio communication. So we're going to jump in and talk about different types of like communications available and NOTAMs. Let me bring up something here really quick. Okay, so we kind of covered the regulatory requirements, what the protocol is for communication, and obviously we have voice communication and data communication when we're talking about ATC voice. We have the capability from a dispatcher standpoint. If we want to talk to our crew on using voice, we can pick up our phone, we can call into Delta Radio or AirRink Radio, or we can even call ATC and even have them patch us in too. There's a lot of different ways that we can talk to our crews while they're in the air using voice, and then we obviously have the data system, that's the ACARS text messaging system. So now we're going to move on and talk about notices to airmen. Those are NOTAMs. But before we do that, let's probably do for another little break here. So maybe it's 10, my clock shows 10:25, so 8:25 your time. Let's pick it back up at 8:40, so about 15 minutes. And then we'll cover NOTAMs and the rest of this and continue on from that point. So at 8:40 we'll resume. All right, well, let's jump in and take a look at NOTAMs. Does anybody know what a NOTAM is or what it stands for?
Just from my experience, it's noticed airmen, so anything happening en route is posted there for pilots to keep themselves aware.
Correct, yeah. It stands for Notice to Airmen. So, NOTAMs, NOTAMs are published by airports, basically individual airports. They published these things called NOTAMs, Notice to Airmen. And what they serve for us, like the purpose that they serve, is to let airmen, so pilots and dispatchers and anybody else using the facilities of an airport or things that the airport provides, they are letting us know of any issues, problems, service irregularities, basically the status of equipment and things like that at an airport. Okay, so we're going to look at them. We as dispatchers, we use and read through NOTAMs a lot. We do it on every single flight that we dispatch. We have to look at these things called NOTAMs. So I'm going to bring some up. I'm going to bring up St. George, first of all. Let's see here. It's going to do NOTAMs. I'm going to bring this up into PDF format for us here. We'll zoom in a little bit better. Okay, so I have brought up the NOTAMs for the St. George Airport. Okay, so the first thing you guys are going to notice about NOTAMs is that there are two different types of NOTAMs. There are these that are called D NOTAMs and another type called FDC NOTAMs. So those are the two different types of NOTAMs that we have. Those of you that are studying for the ADX and things like that, you might see a reference in there to another type of NOTAMs called local NOTAMs, but those have actually since been replaced, and they're all listed under D NOTAM. So just don't let that confuse you if you see that, while studying. But basically, airports now issue only two different kinds of NOTAMs: D NOTAMs and FDC NOTAMs. So a D NOTAM, and what you should write this down here for D NOTAMs. First of all, one thing you definitely want to write down is what NOTAM means. So Notice to Airmen. That's what NOTAM stands for. And then specifically, a D NOTAM. D NOTAMs are for basically giving us information on the status of navigational equipment, runways, taxiways, radios, basically it gives us the status on physical equipment at an airport. So anything that an airport provides, like I say, runways, taxiways, approach, systems, into like an instrument landing system, glide slope, lighting, any physical item that an airport has that airmen use to either navigate or taxi around. Runways, obviously landing and taking off. Any physical piece of equipment that an airport has, it basically would be listed under a D NOTAM. And then FDC NOTAMs cover changes or irregularities with instrument procedures. So now, so FDC, so D NOTAMs is any sort of physical equipment, and FDC NOTAMs is stuff that is not like a physical item or piece of equipment. So
You said changes or irregularities, and then what was the second part? I'm sorry.
On FDC or D NOTAMs?
On FDC, changes or irregularities.
To instrument procedures.
Okay. Okay, cool.
And so with instrument,
Sorry.
yeah, no, you're good. So instrument procedures, we've talked a lot about them already. Instrument procedures would be a SID, a STAR, and an approach like an ILS, a VOR approach, anything like that. Those are instrument procedures. So
Is there any significance to the D and the FDC
well, the
in
D,
terms of acronym?
the D on the D NOTAMs used to mean distant NOTAMs. So yeah, I mean really, so there used to be L NOTAMs and D NOTAMs is what there used to be. Now they're all just considered D NOTAMs, but L used to stand for local and D was for distant. But now they just put them as D NOTAMs, but they're really all for the local airport, if that makes sense. So there's really no rhyme or reason, honestly, other than just they now call them D NOTAMs. And then FDC NOTAMs, I know that FDC does stand for something, but I could not even tell you what that is, and nor do you even need to know it.
Trying to talk your
What's that?
I believe you've muted yourself, Adam.
Oh, okay. Okay, can you guys hear me?
Yeah, you're back.
Okay, not sure what happened there. Anyway, hopefully it's all good now. You guys still hear me, right?
Mm-hmm.
Okay, good deal. All right, so yeah, FDC. I'm not sure where it cut out on me at, but FDC, it does stand for something, but to save my life, I couldn't tell you what that is. So you definitely don't need to know it or will ever be asked about it. But as long as you just know an FDC NOTAM is just for changes to instrument procedures at an airport. That's really the gist of what you need to know of what they cover. So and then D NOTAMs cover any physical item that an airport provides. So we're going to look at these and we're going to learn how to read them. You probably look at it right now and it kind of doesn't really make any sense. So we're first going to look at D NOTAMs. And so I pulled up the ones here for St. George. First of all, we're going to make sense of what all this stuff is here. So the very first thing listed in a NOTAM is going to be the airport identifier. So SGU. So in this case, that's the St. George, Utah airport. So that's the airport code for St. George. The second thing is going to be, this is the NOTAM month and the NOTAM month and NOTAM number is what that is. So the way you look at this is, so this top NOTAM here that we're looking at is, let's see, it is going to be the the 01 stands for January because that is the month that it was issued in. So 01 is January, and then slash, then the 012 is the NOTAM number. So it is the 12th NOTAM of January. Is that how that part there, right there, would be read? So 01 is the month, and then the second set of numbers is the NOTAM number. So 12th is just NOTAM number 12 of January. So that tells you when it was issued. It was issued last month in January. And small airports like St. George, they don't have very many NOTAMs usually. Like this airport only has 2 NOTAMs right now. So then the next part here, sorry guys, I'm not sure what is going on here with my internet connection, but it keeps going off and on. You guys, you can hear me now, I'm assuming?
Yes.
Okay. Sorry about that. I'm not sure what the deal is here. Let me try and mess around here with something for just a minute. Okay. Hopefully we're good. Anyway, so going back to this, so small airports don't have very many NOTAMs. Like in the case of St. George here, there is only 2 D NOTAMs here listed. So first thing is the airport identifier, then the month that the NOTAM was issued, and then the NOTAM number. So 12th NOTAM of January, and then of course you see it says St. George again here for whatever reason. And then the rest of this is going to be, it's basically going to be the issue or the service or item that is affected. And this is saying that, so this is a navigation NOTAM is what this means. So the nav here means that part of it means I don't know why I can't think of the word I'm looking for here, but let's just say it's the subject of the NOTAM. It's the classification of the NOTAM. So this NOTAM is affecting navigational equipment, is what that's saying. And then the specific equipment that it's affecting is the ILS, the Instrument Landing System. Everybody should know what that is now. Runway 19. So the ILS on runway 19, GP, which means glide path or glide slope, so that's the glide slope that we were talking about earlier, is out of service. So one thing you're going to learn, and you've probably already seen a lot of, is that there are millions of acronyms that you have to kind of get used to. NOTAMs are going to be one of those things where there are tons and tons and tons of acronyms that over time you just kind of have to learn and get used to. So you're going to have a lot of practice though reading NOTAMs though, because once again, this is one of those things that we're going to be doing this over and over and over and over every flight plan.
So if you're ILS ground, glide path is out, does that mean you're doing a non-precision in that case during those hours?
Correct. Yeah. So the glide path being out of service means that the only thing on that approach that would be working would just be the localizer. So, but that part, yeah, we'll learn a lot about that part as well as time goes on. But yeah, so for the ILS on runway 19 in St. George, glide path's not working. Now, unless there's another precision approach at St. George that's not attached to this one, then yeah, then there wouldn't, that specific one obviously wouldn't be available. So unless there's another one, then you may not have any precision approaches at St. George at all. So now I can tell you, obviously, just from being familiar with St. George, that is the only precision approach available. So with that NOTAM, that means that there are no precision approaches. There are only non-precision available. And we look at the specifics of that, like I said, later on as we get more into it. But yeah, so St. George, navigational, it's a navigational NOTAM, the ILS, runway 19, glide path out of service. And then this part is the time frame. So the way that this is read is the first two digits is the year. So 2018. The next two digits is the month. So 01, that's January, obviously. And then the next two digits after that are the date, or the day of the month, I should say. So the 17th. So this is January 17th, 2018. And then the last four is the time. And remember, all time, anything in aviation is going to be Zulu time. So that is 2218 Zulu. That is when this begins. Okay, so that is when this out of service glide path started or starts. And then this is when it goes until. So it goes until. So 02 would be your month here. So February 28th, 2018, 2100. And that EST means estimated. So that's not for sure, but that's just the current estimate. So it may or may not be back on at that time, but right now that is the estimate of how long it will be out of service. So, and these are real NOTAMs. So this is the current NOTAMs for St. George as we currently speak right now. So yeah, so that runway 19 glide path is out of service as we speak all the way until the end of this month. So we're going to obviously go over more NOTAMs, but did that more or less make sense to everybody? Any huge questions on how I ran through that? We're going to look at the next one. Just to review. So once again, so this next one here, St. George, this is 03, so that means March. Now in this case, this is March of last year. So this NOTAM has been in here since March of last year. It was the 14th NOTAM of last March 2017. So St. George, and then service, it's in the service category. And then let's see, PCL, off the top of my head, I am not sure what the PCL is. Oh, yeah, actually I do know. Let's see. Okay, yes. So PCL stands for pilot controlled lighting. So not that you need to necessarily know what that means, but pilot controlled lighting essentially is at what it means, just to briefly kind of go over that, is at little small airports that don't have air traffic control towers. The pilots that are just flying around in their planes that want to use that airport actually can control the light systems, the runway light systems from their airplane. And they do that by tuning into the frequency for the airport and clicking their mic button a different series amount of times. So like they may have to click it 3 times or 5 times or 7 times, depending on if which lights and what frequency, not what frequency, but the intensity of the light setting that they want to turn on. But they just tune in, they click their mic, and then what that does is it actually turns on the lights to the runway. So at an airport that has an air traffic control tower, obviously the air traffic control people in the tower will control that for you, but there's hundreds and hundreds of airports around the country that don't even have air traffic control towers. St. George is obviously one of them. And so at night, if you want to come in and land there and the runway lights aren't on, the only way you can turn them on is by tuning into the frequency and turning it on yourself. So PCL stands for Pilot Controlled Lighting for runway 1 is out of service. So the runway end identifier lights are out of service. And it's saying except for low intensity. So it basically means that if you try to turn those lights on, they're not going to come on except for the low intensity setting. So that's just basically a warning to pilots that are trying to turn that on manually from their airplane, that if they try any setting other than the low setting, they're not going to see any lights. So that ultimately is what that means. So pilot controlled lighting, runway 1, runway end, and the ID just identifier or identification lights. LGT stands for lights, out of service. And then EXC stands for except, then low intensity. And that is from March 29th, 2017, 1501 Zulu until, and then the PERM stands for permanent. So that's a permanent NOTAM. Obviously, it's been in there for almost a year now. So until they fix it, at least, that NOTAM's not going anywhere. It's permanently going to be in the system. Any questions on that? We're not going to quite look at the FTC NOTAM stuff yet. I'm going to pull up some NOTAMs for a different airport, and we'll pull up Salt Lake now. I'm going to show you the difference between a little tiny airport and a big airport as far as NOTAMs are concerned. So Salt Lake, you can see my list here, has a lot of NOTAMs. Now, one thing about NOTAMs, and eventually we're going to show you kind of a way to be able to quickly scan your NOTAMs, just like, teach you kind of a method of scanning with your eyes so that you can quickly gloss over the NOTAMs and be able to have the ones that are actually pertinent to a dispatcher, to have those ones stand out, what specifically you're looking for, what words you're looking for. But just so you guys know, as far as a dispatcher is concerned, dispatchers don't care about any NOTAM that has stuff that has anything to do with the aprons, taxiways, anything like that. So, I mean, you're going to find out that the majority of the NOTAMs that you will see aren't dispatcher pertinent. The ones that you care about as a dispatcher, and you'll want to write these ones down, but these specific acronyms that you're looking for. You're looking for ones that say NAV, so like that one in St. George that we read, with the ILS being, the glide path being out of service. That's one that a dispatcher definitely cares about. But looking for the acronym of NAV, look for runway, RWY. Look for ILS, it's the Instrument Landing Systems. Look for VOR.
What was that one? Sorry.
The last one?
Yeah, the one you just barely said.
VOR, like a VOR approach. Look for ALS, which is Approach Light System. Look for AD, which is Aerodrome, so Alpha Delta AD, which stands for aerodrome. An aerodrome, if you see it in a NOTAM, it means aerodrome is talking about the entire airport. So sometimes you'll see a NOTAM, like if an airport is completely shut down for whatever reason, they will close the entire airport. But the way that they do that typically is that they put out a NOTAM that just says SGU AD closed. And that just means St. George Aerodrome closed. That means the entire airport is closed. Not sure if anybody remembers. I'm sure some of you do, but a few years back when that guy broke into the airport and tried to steal the plane and ended up basically shooting himself. He drove the plane into the parking lot and then shot himself. So that's an example of when the aerodrome was closed. The FBI showed up. They closed down the entire airport. Nobody was allowed to land or take off. When they did that, they issued a NOTAM that says St. George AD closed.
Lockdown.
Yeah, and it can be for a lot of reasons. That was that specific reason, but also a couple of years ago as well, when we had the huge St. George snowstorm, like 2 or 3 years ago, we got like 20 inches of snow or whatever. Well, you guys know how snow shuts down St. George. They don't even, there's no snow plows, anywhere. There's no snow plow at the airport or anything. So
I remember it well.
So that was another reason. When it snowed, that they could not remove the snow from the runway, so the airport was closed. It was closed for like 24 hours. Anyway, just another example. If there's too much snow or something like that, they can't get rid of it, or if the runway is like icy or something, you'll see, especially at an airport that only has one runway, you'll see aerodrome closed for that kind of, there's a lot of different reasons, but you can have it where it's just the entire airport shuts down. So, but yeah, that's another one that you want to pay attention to. But other than that, I mean, those are the big things you're looking for. So when you start looking at these, if you can train your eyes, if you can kind of look at this and you can kind of see how if you start looking like kind of at the big picture where you're looking at all of these NOTAMs like up and down the page here, you'll kind of see that there's columns. If you look at this column, you see a bunch of things that say Salt Lake City. If you see this column, you see all of the dates and the NOTAM numbers. This column, obviously, you see the airport identifier again. But if you pay attention to this column right here, if you just simply train your eyes to scan this column and then train your eyes to look for those key acronyms, the ones that I just had you write down, and there might be more we add to this list. I always forget a few, but we'll be making this list. But train your mind to look for the acronyms that we just talked about, and you don't have to look at anything else in this NOTAM. Like if you're just scanning through these and you want to do it really quick, this is how you train yourself. You just set your eyes right here and you just start right here with this word and you just go down. And until you see one of those acronyms that I listed, that's the only time you even stop. So just by taking your eyes right now and scanning this, do you see anything that a dispatcher needs to be concerned about? Any of the items we listed?
Can you say that again?
I was just saying, do you see any acronyms?
No, I don't see any.
Nothing, right? Yeah, there's nothing. So, yeah, apron. This means, obstruction. Obstruction, apron, 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 taxiway, apron, 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 obstruction, obstruction, or obstacle, obstruction. Anyway, okay, let's keep going down. So far, I don't see anything. So we don't even need to read the NOTAM until you see something that sticks out. So, okay, so now I'm down on this lower half. So just remember, this is your column right here. Obstacle, obstacle, taxiway, obstacle, obstacle, obstacle. So you can see a bunch of repeated apron, apron. So far, in lieu of going through and reading all of these things, you can just pay attention to just that column. If you don't see any of your key acronyms, you don't even need to stop. You can just dismiss it, dismiss it, dismiss it. So just as quickly as you're looking at these, you can scan this up and down the page, and you can see there's nothing I even need to read. So, and like once again, these are the current NOTAMs. So currently, Salt Lake City has 0 NOTAMs that are pertinent for a dispatcher. Now, obviously, I kind of still want to go through some of these and just talk about them and have you kind of learn, some of the acronyms and stuff here. But just know that none of these NOTAMs are of any concern to a dispatcher. So I'll just start reading at the top here. So Salt Lake City, this is the month of November, the month of February, NOTAM number 11. So 11th NOTAM of February. Salt Lake City, the category is for the apron. So the apron, air carrier, apron access, number 14 is closed. Sounds like I may be cutting in and out again. Sorry if it sounds bad again. It should only be maybe another 5 minutes or so, then we'll probably be done with class. So hopefully if I can just make it through that, we call it a successful day here, barring these audio issues.